Hello, welcome to Vedil Vagaparai. In this video, we are going to see about enantiomers and their configuration and how to identify a pair of enantiomer in a given question. So this particular video is based on IIT JAM 2017 question. Let's see the question. Among the following compounds, the pair of enantiomer is. So they have given four different structures and they have asked which among these will be a pair of enantiomer. So first, let's see some definitions of enantiomer, and then we will quickly see how to easily solve this particular question. So if you are interested in knowing the basics of these stereoisomers, what are enantiomers, diastereomers, how to assign absolute configuration, please see our earlier videos to get a clear picture of the basics and then come back to this particular question. So let's move to the question now. So enantiomers by definition are nothing but non-superimposable mirror image isomers. So I have given an example here. In this particular set of examples, you see here the left hand side of the molecule is the mirror image of the right hand side. So likewise, in this set of molecules, the left hand side is the mirror image of the right hand side. And what we have to remember is all molecules will have mirror images, but enantiomers have non-superimposable mirror image. It means if you rotate this molecule through 180-degree and place it on this molecule, you will know that CH3 will be here and this phenyl ring will be at the bottom. So such a superimposability is called as non-superimposable. That is, they don't match. When you keep the molecules, when you invert the molecule through 180-degree and place the molecule on its mirror image, then it will not be the same. So such an image or such a molecule which has a non-superimposable mirror image is called as a enantiomer. Similarly, you see in this particular molecule also that this molecule's mirror image is not the same as this molecule. So these two are two distinct molecules. And also you know pretty well when there are two stereo centers. So here carbon 1 and carbon, that is the carbon marked as 1 and 2 are the stereo carbons, and that is they are chiral carbons. And because there are two chiral carbons, we see here there are four stereoisomers because of the formula 2 power n, where n is the number of chiral carbons. Another thing that we must remember is how do I make out whether the given set of molecules are enantiomers? So one of the simplest way is to assign absolute configuration. So when what we mean by absolute configuration is we apply Cannes-Ingol-Prelox rule or the SIP rule and assign configuration for the chiral centers. And then we try to see a connection between them. If the two molecules are enantiomers, they would have opposite configurations at the same carbon. It means, please have a look here, carbon 1 which is a chiral carbon, carbon 2 which is also a chiral carbon are marked. So the absolute configuration at 1 is R and the configuration at 2 is S. So the mirror image will be opposite. 1 will become S and 2 will become R. That is what is stated here. So they would have opposite configurations. So if they are enantiomers, they will have opposite configurations. On the other hand, when we see these two pairs of enantiomers, again, 1 is S, 2 is R. 2 is S, 2 is R. So we see here they have opposite configurations. And what is the connection between these two pairs and these two pairs? Since they do not have such a representation and they are not mirror image isomers, they are called as diastereomers. But the information that we are looking at is how to find the enantiomers and how to find out whether the given set of molecules are enantiomers or not. So now let us go back to the question. So in the question, we are given four different structures. So if you look deeper at each of these structures, we see a carboxylic acid group and an alcoholic group, an amine group, and a bromo group. So these are the four characteristic groups which will help you to first find out whether the remaining three are the same as number one structure. So when we observe the second structure has a carboxylic acid group, but the carbon attached to the carboxylic acid has an amino group. Here, if you see the carboxylic acid, the carbon attached to the carboxylic acid has a bromo group. So this molecule, this carbon has amine attached to it. Likewise, this carbon has bromine attached to it instead of amine. So in total, the structure 2 is an entirely different molecule. There is no connection between 1 and 2. So we can ignore molecule 2. So with this as an option itself, when you see the four options, the options wherein the 2 is used can be conveniently ignored. But then there are three more options. So we'll have to go further into structure 3 and structure 4. So when we see structure 3 and structure 4, again we see it is the same thing as structure 1 in the sense that is the um, groups attached to the carbons are same. So if a carbon has a CH2 group attached to it, it has CH2OH, then it has an NH2 group. If it is a carboxylic acid, then it has a bromo group. Similarly, the fourth carbon also we observe that the carbon that is bearing the carboxylic acid group has the bromo group as that of the first carbon. And also the second carbon has an amino group and an alcohol group. Likewise, this carbon also has an amino group and an alcohol group. So what we observe here is structure 1, 3 and 4 have a similar geometry or similar structure, and but now we would want to know whether they are identical enantiomers or whether they are diastereomers. So in order to understand that, we are going to assign absolute configuration for them, RS notation for them. So let us take the first molecule. So in the first molecule, as we have seen there in the representative example, I am going to mark 1 and 2 for the carbons which are chiral, and I have marked 1 for a carbon having the bromo group and 2 for the carbon bearing the amino group. Similarly, let us go to structure 3. So in structure 3, though it is written on top, it is rotated and written, we are just sticking to the assignment. So the carbon bearing the alcohol and the amino group is assigned 2 number, and the carbon bearing the carboxylic acid and bromo group is assigned number 1. Similarly, we go to structure 4. In structure 4, again, 2 is on top and 1 is at the bottom. So now we have conveniently assigned or earmarked the carbon atoms so that we will be in a position to bring about a relationship between all the three groups. So let us assign the configuration. So when we are assigning configuration, you know pretty well when the least priority group is in the horizontal position, whatever assignment you get, the opposite is the answer. And then the assignment is done based on the atomic number or atomic weight if they are atomic weight of the molecules, that is if they are isotopes that are present, then we make use of atomic weight. But here, because there are no isotopes, we will use atomic number as a reference to assign the priority for the four groups attached to each of these chiral carbons. So now let us start with the structure 1. In the structure 1, bromo group gets the first priority. Then the carboxylic acid group gets the second priority. And the third priority goes to the third carbon, which is the carbon chain length, and the fourth priority to the hydrogen. Similarly, when we see the next set of carbons, again the first priority will go to the amino group. The second priority will go to the carbon bearing the bromo group, and the third priority will go to the alcoholic group. So once we have assigned this, let us see the direction of the arrow or direction of flow of the numbers. So in case of the first carbon, that is one carbon, and then the second carbon. That is how we are going to find out the notation. First carbon, second carbon. First carbon, second carbon. So when you see for the first carbon, number 1 is here, number 2 is here, 3 is here. So the order is in the counterclockwise direction, and because the least priority is in the horizontal position, the answer will be R. So the first carbon is R. Likewise, we see the second carbon. In case of the second carbon, again, the priority is 1, 2, 3, which is in the clockwise direction, 1, 2, and 3, which is in the clockwise direction. But then least priority is in the horizontal direction. So it is S. So the second carbon is S configuration. So for the structure 1, for this structure, first carbon is R configuration, the second carbon is S configuration. So structure 2 is not related to any of the other two because this carbon, which is chiral, has amino carboxylic acid group attached to them, which is not the case in others. So this is an entirely different molecule. So now coming to the next one. Now that we have already assigned priority, we will have to just see the direction of flow of the numbers, priority of numbers. So here we know amino group is getting the first priority. Then we had the second priority to the bigger ring, and then the third priority to the alcohol. So the order is in the counterclockwise direction. So, but then the least priority is in the horizontal position. So the notation will be, in this case, R. So here, this is the second carbon. Please remember, this is the second carbon. So in the second carbon, the configuration is R. Likewise, when we see the first carbon, again bromine will get the priority. Then we have the carboxylic acid group, which gets a second priority, and then the chain. So if you see, they are in the clockwise direction, but then it is yes. So first carbon is yes. Similarly, we will try for the fourth structure, but already we see here in structure 1, the first carbon is R, the second carbon is S, whereas in structure 3, first carbon is S, the second carbon is R. So undoubtedly 1 and 3 are the enantiomers. So the choice which has 1 and 3 is B. So from this options, we know B is the correct answer. But then to doubly make sure that we are not ruling out any mistake, any other answers, we will just check what is 4. So in case of 4, we know again 1, this is 3, and this is going to be 2. So this is in the counterclockwise direction, so it will be R. And here it will be 1, 2, and 3. So this is in the clockwise direction. Sorry, this is also in the counterclockwise direction, and so this will be R. So in case of 4, 1C and 2C both are having the RR configuration. So the enantiomer of 4 must be SS. So but then in this case, when we compare, 1 and 3 are enantiomers, whereas 3 and 4 and 1 and 4 are diastereomers. This is how we can very easily assign configuration and also find out whether the given pair of molecules or the given set of molecules are related to each other or they are unrelated to each other. Hope you understood. Please subscribe to our channel to get more videos on topics of organic, inorganic, and stereochemistry and also spectroscopy. We have put in a lot of videos for you to benefit. Thank you.